Hello, good morning viewers. In today's tutorial, we are going to learn how to find the nth term of binomial expansion using the general formula. So if you are new here, consider subscribing, press the bell icon so that you will be notified whenever I upload a new content, and don't forget to share to your learning colleagues. Don't forget also to hit the like button. Alright, we are given 4 problems here to find their respective terms. So in the first question, we are looking for the fourth term in the expansion of this, third term in the expansion of this, last term in the expansion of this, and lastly, we are looking for the first term in the expansion of 2x minus 2y to the power of 5. So now let's get started. First of all, you should know that that general formula is very important because it clearly states every single term in the expansion. So the formula remains n combination r, a raised to the power of n minus r, b raised to the power of r, where n is the power of our binomials like 5, 3, 5 here, where r is the number chosen out of n, then a is the first term and b is the second term. So all we have to do in every problem here is to substitute n, r, a, and b. Okay, let's start with the first one. The first one, we want to find the fourth term in the expansion of a plus b to the power of 6. We have a plus b to the power of 6, which is our first problem, and we are looking for the fourth term. One thing you should observe is that in the first term, r is equal to 0. In the second term, r is equal to 1. Can you see that r is 1 less than the number of terms? So if you're looking for r, all you have to do is to subtract 1 from 4. So let's start with r. R is equal to 4 minus 1, which is equal to 3. N is equal to the highest power, which is 6. A is A, B is B. So let's substitute here. Therefore, we have n combination r, which is 6 combination 3, because r is 3. Then a raised to the power of n minus r, which is 6 minus 3. Then b raised to the power of r, which is equal to 3. 6 combination r is 6 factorial, divided by 6 minus 3 factorial, then 3 factorial, then multiply by a to the power of 3, because 6 minus 3 is equal to 3, multiply by b to the power of 3. This is equal to 6 factorial divided by 6 minus 3 is 3 factorial, multiplied by 3 factorial, a cubed, b cubed. All right, now let us simplify the factorials. This is equal to 6, 5, 4, 3 factorial. I will stop here because I have 3 factorial down here. So from here, 3 factorial will cancel 3 factorial. And 3 factorial, remember, is 6. So let me even break this down. 3 factorial is 3 times 2 times 1. 3 times 2 is 6, so it will cancel this. All we have left is 5 times 4, which is 20. So finally, we have 20 a cubed, b cubed. So this is the fourth term in the expansion of a plus b to the power of 6. Now let us take the second problem. The second problem, we have 2x minus 3 to the power of 5, but we are looking for the third term. Two x minus 3 to the power of 5, and we are looking for the third term. From here, you can see n is equal to 5, r is equal to 3 minus 1, which is equal to 2. a is equal to 2x, then b is equal to -3. This is our data. And the formula remains n combination r, a raised to the power of n minus r, b raised to the power of r, which is equal to n is 5, combination r is 2, then a is 2x, so we have 2x to the power of n minus r, which is 5 minus 2, multiplied by b, and b is -3, to the power of r, and r is equal to 2. So 5 combination 2 is written as 5 factorial divided by 5 minus 2 factorial, then 2 factorial, multiplied by 2x to the power of 5 minus 2, that is 2x to the power of 3. Then -3 squared is 9. Let us further break it down. This is 5 factorial divided by 5 minus 2 is 3 factorial, then 2 factorial, multiplied by 2 to the power of 3 is 8, x to the power of 3 is x cubed, then multiplied by 9. 5 factorial is 5 multiplied by 4 multiplied by 3 multiplied by, okay, let me stop here because I have 3 factorial down here. We have 3 factorial multiplied by 2 factorial is 2. So this will cancel this, and 2 can go into 4 2 times. We have times 8x to the power of 3 times 9. So 5 times 2 here is 10. So this is 10 multiplied by 8x cubed times 9. So let us multiply 10 times 8 times 9. 10 times 8 times 9 is 720. So we have 720 x to the power of 3. So this is the third term in the expansion of 2x minus 3 to the power of 5. Let us take problem number 3. Problem number 3, we are looking for the last term in the expansion of x plus 2y to the power of 3. X plus 2y to the power of 3, and we are looking for the last term. So let's write the data. N is equal to 3 here. Then which one? R is equal to 3 as well, because in the last term, R is equal to N. That's what you should know. Then A is X, B is 2Y. Then for the formula, it remains N combination R, A raised to the power of N minus R, B raised to the power of R. And this is equal to N is 3, combination 3 again. Then A, which is X, to the power of N minus R, that is 3 minus 3. Then B, which is 2Y, raised to the power of R, and R is 3. Remember that N combination N is equal to 1. Therefore, 3 combination 3 is equal to 1. So we have 1 multiplied by x to the power of 0, because 3 minus 3 is 0. Then multiplied by 2y to the power of 3 is 8y cubed. This is 1 because x to the power of 0 is 1. So we have 1 times 8y to the power of 3. Finally, we have just 8y to the power of 3 as our last term after expanding x plus 2y to the power of 3. Now let us take the last problem. The last problem, we want to find the first term in the expansion of 2x minus 2y to the power of 5. 2x minus 2y to the power of 5. We are looking for the first term. Remember, in the first term, r is 0, so n is 5, r is 0, a is 2x, then b is negative 2y. Therefore, we have n combination r, a raised to the power of n minus r, b raised to the power of r, which is equal to n is 5 combination 0, a, which is 2x, raised to the power of n minus r, that is 5 minus 0, then b, which is negative 2y, raised to the power of 0. Also, you should remember that n combination 0 is equal to 1. Therefore, 5 combination 0 is also equal to 1. So this is just equal to 2x to the power of 5 minus 0 is 5. Then multiply by, okay, this is also equal to 1. So we don't have to multiply by anything because negative 2y to the power of 0 is equal to 1. So all we have is 2x to the power of 5. We have 2 to the power of 5, which is 32. And x to the power of 5 is x to the power of 5. So this is the first term in the expansion of 2x minus 2y to the power of 5. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye.